to start the second topic, mechanical properties of fluids. Mechanical properties of fluids. And this is our lecture number 1. Here, first we will see what is meant by fluids. Fluid, it is a substance that can flow. A substance which flows is called as fluids. Therefore, we consider here liquids and gases. Liquids and gases. They flows from one place to another place. So we call them as a fluids. And also one state of the matter, that is plasma. This is also we consider a fluid. And here for fluids, the shear modulus is always 0, because the shear modulus is related with shape of the body. Hence liquids, gases, plasma, they doesn't have regular shape or fixed shape. So we consider here the shear modulus for these bodies is 0. And these fluids, that means liquids, gases, plasmas, they floats from one place to another place under the action of force or pressure gradient. That means if we apply the force, they flows. Also whenever there is a pressure difference, then they flows from higher pressure to lower pressure. This is the fluids flows from one place to another place under the application of force or pressure gradient. Now we consider the ideal fluids. The properties of ideal fluids. Properties of ideal fluids. Ideal fluids. First thing, that is incompressible. Means density is constant. Now second property we consider, that is flow is irrotational. Flow is irrotational means flow is smooth flow. That means turbulence is absent. That means irregularity is absent. This is second property. Now we consider third, non-viscous. That is internal friction is absent. Non-viscous. That means the fluids have no viscosity. And fourth one, that is flow is steady. That means velocity at any point is constant. These are the 4 properties of ideal fluids. That means incompressible, density is constant, flow is irrotational, smooth turbulence, flow is smooth, turbulence is absent, non-viscous means internal friction is absent, flow is steady, that means velocity at any point is constant in time. These are the properties of ideal fluids. Now we will see properties of only fluids. That is properties of fluids of our ideal fluids. For any fluid we consider they do not oppose. They do not oppose. Do not oppose deformation. That is, they get permanently deformed. They get permanently deformed. Second, they have ability to flow. They have ability to flow. And third one, they have ability to take the shape of container. These are the three properties of fluids. Now we will see next one, hydrostatics. See here, what is meant by hydrostatics? This is the branch of physics which deals with the properties of fluids at rest. Is called hydrostatic. That means the branch of physics. Hydrostatic is branch of physics. Which deals with the properties of fluids at rest. This is hydrostatics. Now, next we will see what is meant by pressure. Suppose F is the force. We consider here normal force on the walls of the container. A is the surface area. Then pressure P is equal to F upon A. Now from this formula, unit of P is Newton per meter square, or we consider next 9 CGS dynes per cm square, or Newton per meter square is also called as Pascal. 1 Newton per meter square is equal to 1 Pascal. Also, another unit, 1 bar is equal to 10 raised to 5 Newton per meter square, and 1 hectopascal is equal to, we write here 100 Pascal. And dimensions, that is dimensions of force M1 L1 T minus 2, and dimensions of area, we write L2. That means if we consider here total, that is M1 L minus 1 T minus 2, these are the dimensions of pressure. Now we consider next one, pressure due to liquid column. Suppose we consider liquid is in this container. Suppose this is the container. In this we consider, suppose this is the liquid. This whole is the liquid. Now we have to obtain the pressure due to the liquid column. Now we consider here small cylinder like this. This is the small cylinder of height h, and we consider A be the area of cross section. Here we consider this is the air, and here we consider suppose water or any liquid, and in this we consider a small cylinder having area of cross section A, and h is the height. Now here pressure P pressure P is equal to F upon A. Suppose this is equation number 1. But we consider F is equal to mg. Mg means weight of this column, or we write here AH rho g. Suppose this is equation number 2. And therefore we write here P is equal to F upon A, which is equal to, we write here AH rho g upon A. This A gets cancelled, and therefore we get here P is equal to H rho g. Suppose the equation number 3, this is the pressure due to liquid column having height h. Now we consider next one, atmospheric pressure. Atmospheric pressure. What is meant by atmospheric pressure? At any point, we consider, suppose at any point the atmospheric pressure is weight of a column of air of unit cross sectional starting from that point and extending to the top of the atmosphere. Suppose we consider this is the point. Then we consider weight of the air column. See here. Suppose this is the air column of unit cross section, and this is the air column of unit cross section and extending up to the top of atmosphere. Now the atmospheric pressure at sea level, we many times we measure at sea level. Then this pressure at sea level we call it as a normal atmospheric pressure. The density of air in the atmosphere decreases as we go to the height and becomes negligible beyond a height nearly equal to 8 km. So that the height of air column producing atmosphere pressure at sea level can be taken as 8 km. The region where pressure is less than atmospheric pressure is called as vacuum. That means the pressure, whenever it is less than atmospheric pressure, then that region, that we can call it as a vacuum. This is all about atmospheric pressure. Now we see next article in next period. Thank you.